Okay, so HDFS stands for Hadoop Distributed File System. It is Hadoop Distributed File System. So we should make input data available in HDFS. After that, we'll process the data. So what is a data processing system in Hadoop? The data processing system, that is, we use MapReduce to process the data. Or in the Hadoop new environment, instead of the MapReduce, we can able to use Yarn 2. Either decide you want to use MapReduce or you want to use Yarn, where Yarn stands for yet another resource negotiator. So now the Hadoop is a combination of HDFS and MapReduce or Yarn, right? The data is available in HDFS and the programs are the jobs which we are going to process the data is done with a MapReduce or with a Yarn. Okay, now so how the data is going to be distributed now? So the data is going to be distributed to these nodes, right? How many nodes are there? In each node, the data is going to be distributed equally. Suppose I'll take a simple calculation here. Suppose I have a file. The file name is pradinfo.txt. Okay, consider this file contains 1000 GB considered, right? Now what we want to do, we want to write this file into the Hadoop cluster. Okay, so when you are going to write this file into the Hadoop cluster, now the file is going to be distributed into small size of chunks, right? I am writing here the each input data, right, is right distributed as small size of chunks. Okay, so we call these chunks as blocks. That is the input data which we are going to write into the cluster is distributed into small size of blocks. How many blocks? See, in the Hadoop we have the different block sizes available. Each block size, or you can say, suppose if your default block size is 64 MB, each block size, default block size, and our file is take, it's a, for simple calculation I am taking 1 GB file, 1000 MB file, right? Now how many blocks are going to be created? The file size is 1000 MB and in Hadoop cluster the block size is 64 MB. That is, if you divide 1000 by total file size by one block size is 64 MB, that is it comes to 15.6. That is total 16 blocks are going to be created. Okay, total 16 blocks means we'll get a one block 1 and block 2. Like how many blocks we'll have? 16, right? Total 16 blocks are going to be created and each block is replicated, right? So we have a replication, so that if your one data node goes down, we'll have the replication, that is duplication of that block in some other node. So each block is replicated. Replicated in the sense repeated again, a duplicate, another copy is going to be created. That is, the default replication is 3. That is, every block is going to be replicated 3 times. That is, block 1 replicated 3 times. Okay. Similarly, the block 2 also replicated 3 times, because your replication factor is 3. That is, every block we are having is going to be repeated, duplicated to the 3 times. Now these blocks are equally.
Actually,
Yes, yes, Prithvi.
why, why 3 times?
uh, because it's a default replication is 3.
Why three?
Why 3? Because suppose you're having this black one in this disk is available. Okay, right? We suppose we have not replicated 3 times. Okay,
Okay.
the black one is available in this SDFS. Now, because of some activity, this particular data node goes down, failure.
Okay.
Then how you get the data? You're going to lose the data, correct? So,
Yeah.
so what I'm doing now? So each block I'm making 3 copies, and I'm writing 1 copy in one data node, and I'm writing the second copy in this data node. So the same black one I'm writing here, and the same black one I'm writing here.
Okay.
Okay. Now, if your this node goes down, this case goes down. Now what we'll do now? We'll retrieve the data from data node
This
2.
problem.
Right. So this is the reason to make the data high availability. To make the data complete available, we are going to replicate multiple times. That is, by default it is 3. We can change it up to as you want.
What's the maximum?
This is 3. Generally, everybody will replicate only 3 times.
Okay.
Okay. So this is the default replication block. So if we go a little bit more, so we have a property. The property name is dfs dot block. Okay, this properties value will be specified as 64 MB. Right? It is in a configuration file, Hadoop configuration file. That is, the file name is sdfs-site.xml. Right? I'll teach you this again in the Hadoop configuration section. Right? As of now, remember this. Okay, so default replication is 3, so each block is going to be replicated 3 times. So because we have replicated multiple times, so and after that it is going to be equally distributed, so that block 1 is placed into the node 1, block 1 is also placed into node 2, block 1 is also placed in node 3. So if your one disk is goes down, so that we are going to continue your our job processing with the same data with a different data node, right? So this is the reason we are making the replicated blocks. Okay, now Sindhuri, are you clear?
Thanks.
Yeah.
Yes, Ajay.
Yes. And here no need to mute Sindhuri and Prithvi, so these are all the interactive session. Okay,
Okay.
right? So no need to make yourself mute. Yes, you can simultaneously will have the conversation. It's my sessions are right, these are all interactive sessions and complete practical oriented sessions. I'm going to show you every example practically, which you have to do in your office. I'll take the real time role based examples. So just try to learn, and the same job, if you assign as a Hadoop developer, same task will be given to you. Now learn how to do here with a small data. There you have to do with a little bit big size data. That's it. Only the difference. Okay. Right now, so like we are having the blocks. Correct. Now, so where actual data is available, this in this 3 data nodes, we have actual data, right? As a blocks are available. So we call these nodes as data nodes, where input data, our data is available. So it's a data node 1, it's a data node 2, and it's a data node 3. We call this as a data nodes. So where actual data is available in the data nodes. Now we'll confuse, correct? Suppose we are writing multiple files. Then which file is available in which disk? How to identify that? Right? It's a difficult. So that we have another node which we are calling it as a name node, which will contains the reference of the data in a data node, so that which data is available in which data node will be written into the name node. Okay, so it will be written into the name node. So now what did you understood here? So the data nodes are the nodes where actual data is available, and name node is a node where it contains the reference of the data which are in the data nodes, or you can say the index of the data. You can call it as a index of the data, or we can call it as a metadata, or it is a tree kind of structure. What is a tree kind of structure here? Suppose I'm going to write a file to a specific directory in the Hadoop cluster. In a directory with the name user, we have a subdirectory Cloudera. In that one, I have created a directory with the name Prithvi. Right? I have a file. Which file? Some prad info file is there. Right? Now, this path, only this particular path written into the name node, and the content of this prod info are going to be distributed as a blocks, replicated and distributed to these data nodes. Now you got it, what a name node contains and what the data node contains. Sindhuri?
Yeah.
Ajay, you said before some master node, right?
Yes, yeah, that's again I'm coming. So this is a master node, right? So as of now you got it, what a name node contains.
Yes.
Yes.
Yeah, it is a index or metadata or a tree kind of structure which contains the location which file is available in which directory. So this reference is written into the name node, right? So we are making the same blocks multiple times, so that if your data node goes down, we can retrieve the data. But suppose if your name node goes down, can we able to identify the data, which data is available in which data node? If we don't know this
Yes.
path, no, we cannot able to identify, correct? Because suppose you have given a textbook of 1 lakh pages, and I told you to search for a paragraph where there is no index, there is no bibliography. Can you able to identify?
No.
No. Even if you have a bibliography or an index, we can able to identify. Similarly, in a cluster, name node is a single point of failure. That is, if your data node goes down, nothing is going to be happen. But if your name node goes down, that is, entire cluster is down. Okay. So how much a name node
Okay.
is important? Because if there is no name node, then we are unable to identify which data is written into which data nodes. So when we don't know which data is written into which data nodes, it's a waste of the thing to have the data into the data nodes, correct? So that if we
Yes.
know the reference, then only we can able to travel to that particular node to get the data. So if your name node goes down, right, the entire cluster is down, so we don't accept that kind of things. So what we'll do now, immediately we'll have the two another name nodes, right? One is a secondary node and another one is a high availability node, right? So this is a primary name node, then it will be secondary name node, and other one is a high availability node. right? So these are the backup copies. High availability node is a backup copy,
Where,
and right. So whatever you are writing in
where,
then this name node, same is written into HA node, right? Every whatever data is available in this machine will also be written into this node, HA node. So if your name node goes down, what happens? Because we'll have the same data is available in HA node, so we'll make this as a name node. Got it now? So that's what we call it as
Ajay,
a high
Ajay, can
availability
you
node.
say
Yes,
Ajay, can you say again what HA stands for?
high availability. You can say it's a
where
different.
are these?
Hello, it's a high availability node or it's a backup node.
Yeah, where are these high availability nodes and name nodes are stored basically?
They are the machines, they are the disks. I'll show you that one, right? In when we are moving to the topics, I'm going to show you where is a name node, how to go through that one. I'll teach you just as a conceptual one, right? As of now in this today's session, so just learn the conceptual wise, okay, how we are going to organize the data. And we have this architecture session again in the chapter 3, where we are going to dig deep into the architecture, okay. Basically it's for which we are going to continue with the programming from tomorrow onwards. So this is a let's overview how we are having the data, okay. So what I am saying here is, now we are going to write this reference into the name node. The same data which you are going to write into the name node is also we are writing into the HA node. That is, name node and HA node contains same rights. So that if this particular node goes down, what happens now? Because we have the data available in HA node, so we'll make this node up and running so that we can able to identify which data is available in which data nodes, okay. So this HA node stands for high availability name node. SNN stands for it is a secondary name node. It is a secondary name node. Right now, see here what Hadoop architecture we are calling these name nodes as a master. You there, Sindhuri? Prithvi, can you able to hear my
I have,
voice? Okay,
yeah,
fine. Right now, so these are the name nodes. Two name nodes generally will have, and this is the data node. So if your name node goes down, we'll continue with the high availability node, right? So now, so these name nodes we call it as a master nodes, and so these data nodes we are calling it as a slave nodes, right? So what is a Hadoop architecture is in the form of master and slaves. So where what is a master node? Name
it's a
node.
name node which
Name node
teaches
is a
data.
master node, and secondary name node is a master node, and HA node is a master
High
node,
availability.
right? What are the slaves? All data nodes are the slaves, okay. So now where we are having the data and how the data is going to be organized into the cluster. Now you have an idea, Prithvi, so how your
Yes,
input data is written into the cluster.
yeah,
Yes, so this is now the complete file is a combination of block 1 to block 16, okay.
okay,
Now, so apart from this data storage, so we have some data processing is to be performed, right? So this is now we are getting the input data to the cluster. After that, we have to write some jobs, correct? So
yeah,
that execution of the jobs can be done by the job tracker, okay. We'll have a job tracker. Where we'll have the job tracker? So job tracker resides in the machine where name node is available. Okay, job tracker is a process which will execute the job. Okay,
Okay.
suppose
Okay.
in your system, right, it's a client, means your system, you wrote some program, that is you wrote a query like this: select count of star from prod info. You write a query like this, and you wrote this in the terminal. You have pressed the enter button, right? So whenever you press the enter button, means this query has to be executed. Correct, Prithvi? That is, now the job tracker will take this query from the client. Who will take the job? Job tracker will take the job from the client, and it checks in the name node that in which data node, in which data nodes in a cluster the prod info file is available. Okay, what job tracker will do here? Job tracker will take the request from the client and it goes to the name node. In the name node, it will identify in which data node the data is available, right? That is identified by the job tracker. After that, it will identify, okay, this prod info is available in some data nodes, 1, 2, 3, it knows. After that, it will assign the job to the task tracker. That is, in each data node, we'll have a task tracker. Okay, means job execution, who it is a process which executes the job. Okay, so in data node, right, just try to remember as it is. If don't think anything about right now, okay, so you'll get end up with some confusion. Okay, now see, in every data node, just try to remember as it is. What you have to remember, in a name node we'll have the job tracker. In each data node we'll have one task tracker. This task tracker will responsible to execute the job. Now see here, job tracker will take the input from the client and it searches in the name nodes metadata. It gets the information that in which data node these prod info blocks are available. Then job tracker goes to that particular data node and it will assign the job to the task tracker. Now task tracker will take the job from the job tracker and task tracker will execute the job. Once the job is completed, output will be given to the user, right? So this is how your job is going to be processed. I'll repeat. So what you have to remember, the first point, name node contains metadata. Name node contains which data node will have which data is written into the name node. Second point, actual data are written into the data nodes, right? In each data node we will have a one task tracker. In a name node we'll have a job tracker. Okay, in a machine where name node is running, their job tracker is available. In some bunch of machines nodes which are configured as a data nodes, so in each data node we'll have the task trackers. Now the client request is taken by the job tracker and job tracker goes to the name node. In the name node it will identify in which data node the data is available. After that, in that data node it will identify one task tracker and it will assign the job to the task tracker in that particular data node. Now task tracker will execute the job and output of the job is given back to the client. Okay, Prithvi?